To clean the board from flux, you must first invent a universe in which the board is dirty.
We inhabit such a universe. Before us lies the Gigabyte Z590, a microcosm of silicon and copper, a galaxy of potential waiting to be unlocked. But its central star, the LGA 1200 socket, has gone supernova. It is a dead sun, and we are the cosmic engineers tasked with igniting a new one.
We begin by returning this miniature cosmos to its primordial state. We apply heat, much like the universe in its earliest moments, shortly after the Big Bang. The board, currently a cool, dense state of matter, must be warmed. We are inducing a localized epoch of recombination, where the energy density is high enough to liberate the metallic bonds of the solder. The protons and electrons of the tin lead alloy are becoming excited, preparing for a phase transition of cosmic proportions.
The moment of stellar death is upon us. With the focused energy of our thermal lance, we bring the solder to its melting point. The old socket, a red giant at the end of its life, is released from its gravitational binding. We gently lift it away, a dying star ejected from its host galaxy, leaving behind a nebula of molten metal. The void it leaves is a black hole, a region of space where no processor can exist.
The aftermath of the supernova is a chaotic nebula of excess solder. To prepare for a new genesis, we must bring order to this chaos. We introduce our copper wick, a cosmic broom sweeping across the galactic plane of the PCB. The molten solder, like primordial hydrogen and helium, is drawn up into the braid, leaving behind a field of perfectly flat, pristine pads. The cosmic dust has settled. The stage is set for the formation of a new star system.
And now the nebular hypothesis in action. We introduce the new LGA 1200 socket, a protostar composed of polymers and gold-plated contacts. We align it with the precision of celestial mechanics, ensuring each of its 1200 pins finds its designated orbit on the pads below. Once again, we apply the energy of creation. The solder spheres melt, fusing the new star to the galactic framework of the motherboard. A new solar system is born, ready to host the complex life forms of an 11th gen Intel CPU.
Alright, and we're done replacing the socket. Yeah, I would use Carl Sagan voice, but I ran out of tokens, so you're gonna have to settle for my voice. Now the cleaning. Take a look at it. Omega 559, the new formula. I've been selling it for a while, so if you ordered in the last couple weeks, you definitely got this blend, not the previous blend. The previous blend would turn into a rock, essentially. It would create this layer that you would not be able to remove, right? It still can be cleaned with isopropyl alcohol, but you have to soak it for a long time for it to actually clean, and then some ultrasonic cleaning, and it would sometimes take a long time of ultrasonic cleaning to clean it. As you can see, this one doesn't burn even after heating to 218 degrees for quite a few seconds. It remains liquid and it is easy to clean with dry Q-tip, or at least the majority of it. Obviously, that's not gonna clean all of it. So first, what I do is I get a paper towel, and actually first let me show you under the scope what happens when you spray alcohol in it, and you see how the flux starts dissolving in alcohol. Right, so we can leave it like this for a little while. Right, I even sometimes cover it with a little plastic box to slow down evaporation, but you don't have to do that. So I put the towel over here, I put the bore at the angle. It doesn't have to be this steep angle like I have right here. It can be a little more shallow angle like this. It's the best when it's a really shallow angle, but around 45 degrees is perfectly fine. So first I just spray it and just wait, nothing more. Right, we're not using ultrasonic cleaner, and as I always say, if you don't have to use an ultrasonic cleaner, don't use it. It can make a lot of damage. And what you're gonna see is how the towel at the bottom is getting yellow. So first I keep spraying it until the towel stops getting yellow. Right, this will take quite a few sprays of isopropyl alcohol to achieve, but you do it completely without any damage to the board, without risking any damage from the ultrasonic cleaner. And after a few minutes, you can see how yellowish the towel gets, right? And that's probably all we can do for now. Although you'll notice that the flux is going to start pooling at the bottom, right? So the top of the socket is going to be cleaned first, and then everything is just going to flow down. Between the cups and the cups, these are difficult to clean. Now we can use a brush and just brush them to kind of speed the process up, but there's even a simpler method. We set 220 degrees on the header station, full blast, but you don't have to do full blast, and just start blowing from the top. So this serves two purposes. Number one, it blows hot air, obviously, so it pushes the flux. Number two, it heats up the board, so the flux becomes easier to mix with alcohol. Now it'll dry, all the alcohol will dry out, and also after this, you see how the residue stays on the pins or around the socket or on the cups, because when it's drowned in alcohol, you can't really see that. You see that best after drying. Right, and now it's nice and hot, so let's spray it again, and now you see a lot darker residue coming from the socket. See how dark it gets now, because the flux got loosened up by the heat. Spray it a little bit and repeat a few times. Okay, all the flux is now in our paper towel. Right, so let's replace the towel. As you can see, there's plenty of it here. Remember not to drive after doing this for at least give it an hour. You don't want to get a DUI because you were cleaning the board. New towel. Now looking at it now, it's perfectly acceptable. What you don't want to see are kind of discolorations on the socket, on the pins. Right? At every angle, you want to see roughly no spots. Right? Those spots means that there's a flux left somewhere. So if it's uniform, it's perfectly fine. Now let's take a look under the microscope. So all the pins look clean, and the socket and the edges and stuff, we don't see any specks of flux. Now the cups could use a little bit longer. Now we could keep repeating this and it'll get perfectly clean. We could subsidize with a little brush and just keep brushing it like this, but be careful because it's very easy to bend the pin. Right, so that will speed up the process. If you just continue doing this, it might take a while, but those cups don't have to be super clean. We definitely don't want any flux left over on the socket. On the cups, this little residue is fine. It's not gonna hurt anything. But what I do is I just put it in the ultrasonic cleaner, but I don't turn on ultrasonics, I just turn on the heater. I raise the temperature to 55 degrees and I keep it for as long as it needs, right? It's not going to dissolve, it's not going to hurt the board. If it's really stubborn, I'll put 2, maybe 3 minutes of ultrasonics and then it comes out super clean. But with this alone, just spray it, heat it up and let it flow down. If it doesn't want to leave, spray it and give it a little bit of brushing just to help dislodge all the little specks that might be left behind. Now you will find that it's a lot more difficult to do the edges without damaging any pins. You definitely don't want to bend any pins at this stage because you just put in a couple hours into replacing the socket. So we don't want to, for the sake of keeping the cups super clean, you don't want to damage the socket. But that's what I'm gonna do because I'm lazy and I don't really have much time for this. So I'm gonna put it in the ultrasonic cleaner, set it to 55 degrees and leave it for maybe half an hour. And that will conclude the repair. Alrighty, hope you guys found this useful. Thank you very much for watching and I shall see you guys in the next one.